Hello, everyone. This is Elisa Baum. I'm GridGain Systems Director of Product Marketing. We will begin in just a moment, but I need to conduct a little bit of housekeeping. I just want to let people know that during this webinar, they'll be on mute, and should they have any questions, they can go ahead and enter them in the questions window in the GoToWebinar control panel, and I'll make sure that everyone has a copy of the slides and the recording within 48 hours after the event. I'd like to thank you for joining today's webinar. It's called Real-Time Financial Data Analysis with In-Memory Computing. It's being presented by financial services industry consultant Eric Cartman and GridGain Systems Technical Director Matt Sorrell. And with that said, I'll turn the floor over to Eric. Go ahead, Eric.
Thank you, Alyssa, and good morning, good evening, good afternoon to the audience. I know you're usually located in various parts of the world, and that's great. So we'll try to cover a global perspective of this topic. And like Alyssa said, it's a very exciting topic today, where we'll talk about data, what the different types of data financial services companies are utilizing, and what they can do with this data, and especially how the in-memory computing can help with that data analytics that's so needed in financial world today. So let me start with first sort of the overview of where the data is coming from and what some of the sources of that data and how that data is growing. I would say that there is a continuous flow of data. A lot of data has been coming from multiple sources for analysis, for decision-making processes, for regulatory reporting, basically for any kind of needs where financial services firms need to present this data either to regulators or to customers or to make internal decisions. As you can imagine, financial services industry is amongst the most data-driven of all industries. And the regulatory environment that the banks operate within requires these institutions to store and to analyze many years of transactional data and to use it for their decision-making power. And so that means that they need to process this data coming in real time. Those are maybe the trade, market data and trade details coming from the markets. That may be customer actions and transactions that are coming in. That may be a different news that are coming in from, the markets and so on and so forth. And more than 2.5 quintillion bytes of data added daily on a global scale. And what that means is that a lot of data is processed. Some of it is just being sort of processed once, but a lot of data needs to be stored for historical analysis, for regulatory compliance and things like that. And so the data must be available because, again, the regulators and other sources or other forces behind the data retrieval can come in at any time and request this data. There's the idea of democratization of data, that data must be available to various applications within the enterprise, right? So it's not trying to eliminate different data silos and trying to create a lake where the data is flowing and becomes available to different applications on demand. Data becomes the main source of decision making and analytics within the enterprises. There's IT governance that's being set around data with the establishment of chief data officers and the whole data governance around processing and storing of data. There are innovation labs being set up where new ideas are being used on how to more effectively and efficiently utilize the data for decision-making capabilities. I mentioned regulatory requirements, and obviously there are different governments and different regulators are coming to this area and demand that the data being captured and stored in a particular fashion, so that the data privacy and privacy of clients operating within the financial services ecosystem is being stored and secured. There is a clear shift towards digital data processing and straight-through processing, where the data can be analyzed and used without any human interruptions in the process. The technology by itself is becoming more affordable, and so that's also driving the data growth. As we don't need to worry about a certain data that should be stored and other data that should be moved to an offsite location. Now, as the storage becomes cheaper, there's more and more data being stored locally within the data centers of the enterprises. There are innovative services around data, right? So we all know Uber and other type of analytical companies that analyze data to really create pricing, to create and modify pricing models in real time, to utilize data that's available to better serve and better charge the customers in real time. Business intelligence is also part of that, where you can, again, in real time analyze the behavior of customers and then make decisions on the fly. Also, we're seeing more and more data being outsourced, right? So if instead of all companies subscribing and reusing the same data, maybe there is a better way of storing this data centrally on the cloud somehow, and through a subscription model, having companies come in and pick the data that they need instead of actually storing, processing, and handling the data internally. And then there's also outsourcing, where again, maybe it's a cloud or maybe it's not a cloud, where somebody else is going to be helping you to manage and work with your data. There is a graph here that I think is also quite interesting. It talks about big data, and we'll talk about big data in a second, but big data market is basically growing about 45% annually, and that's a huge growth, as you can imagine. So that means a lot of data being accumulated, but not in terms of the size of data that much, but in terms of the analytical capabilities of this data and having an ability of processing this data smoothly so that the business decisions can happen instantaneously. So what are some of the data types? What makes a big data one of the most critical aspects or terms we use today in the data processing world? The data comes from multiple sources, as I mentioned before, and we usually categorize it into two areas. One, we call it structured data, basically all the data that has a certain predefined number of fields and the size of those fields, and you precisely know for each record how long this record is and where within that record certain data resides. And that may be any kind of transactional data like payments, for example, maybe market data that's coming in from the exchanges in a predefined protocol like FAST and FIX and those types of protocols. There's reference data, right, that's coming in from different entities and that tells you about new securities that have been issued, securities master and things like that are being updated through the reference data updates. Pricing, right? So again, as the markets change, so is the pricing for each security. And if you need to in real time understand how much your portfolio is worth, you want to receive those price updates from the market. And again, it usually comes in as in a structured data format. Risk, again, as you are accumulating securities in your portfolios, you wanted to know how they are correlated to each other, how the risk factors line up based on what's happening in the market. And again, you receive those updates in a structured manner. Traditional databases by themselves, those relational databases, are also considered to be structured data because we have the tables, we have the formats of each field, structure of each field. So therefore, any of those objects coming in from the relational databases are usually also in the form of structured data. But the real growth in the market is coming from the unstructured data category. Right, that's where all those emails, documents, spreadsheets, images, telephone conversations, videos, social media updates, news, anything that you are receiving to sort of update your knowledge about the world, about the markets. That's usually coming in an unfiltered, unstructured way, and you need to again find a way of deciphering information from within those unstructured data pieces, and that's where a lot of processing and performance of the systems usually taking place to actually get the data from those unstructured data sources. As I said, big data is a term that we usually use to associate with some kind of large or complex applications that handle a lot of data, but not so much in size, but also in the ways that they can extract the data and they can make it, make use of analytics around this data in a real-time fashion. We also, in many cases, talk about 3 V's when we talk about big data. What are those 3 V's? The volume, variety, and velocity. Well, the volume refers to the quantity of the generated and stored data, meaning that what is the size of the data and how to better handle that size in a optimal fashion so that there's not a big performance drain on dealing with such a large volume of data. Second V is for variety, which is the type and the nature of the data, right? This helps us to analyze this data effectively using the knowledge about what is the type and what is the different sources of data and what is inside of that data category. And then the third one is velocity. In this context, it's the speed at which the data is generated and processed to meet the demands and challenges related to the data processing. Right. So again, all of that requires volume, requires a lot of space to handle this and to make it available. Variety means your system has to be able to handle very structured and unstructured components of the data. And velocity means that you will be able to do it fast in some kind of fashion that's business friendly, that you can, maybe it takes milliseconds, maybe it takes seconds, but it shouldn't take too long to process the data because otherwise it becomes unusable. Obviously, there are challenges with big data and processing of data. Well, some of the challenges I'm listing here. One of them is noise, is that you have to be able to separate the relevant data from useful data as this data is coming in from those multiple sources that I mentioned before. Right? I said there's some unstructured data sources, and some of the information may be useful, some of it may not be useful. So you need to be able, from the context, from the source of where it's coming from the the market situation and so on, decide whether this is a relevant piece of data or not. Also, how to discover the data, how to know where to take the data from. And how to know that the data has been updated from the source you're taking it from, things of that nature. And then the data quality. Overall, you may have multiple data sources for the same data data information that you're looking for, and then you need to decide where there's a better quality of this data. I mentioned earlier data governance, so you need to have a system around how the data is accessed, who can have access to this data, audit anything that happens that is related to accessing and processing of data, basically creating some kind of a transparent structure around handling of data. And there are also disruptive technologies, right? There are many companies, many ideas that are coming into place to the banks, to financial institutions that sort of also deal with data, and then you need to decide whether those technologies may help you to get better quality of data and faster data processing, or they may actually disrupt your business and your customers may go elsewhere because the data is cheaper and maybe more analytics is available from some of those companies. Obviously, reputational risk is key here, that in case a data gets stolen, or in case somebody who was not authorized to see a data has gotten access to this data, obviously some of those cases create reputational risk for the whole company. And then the cyber risk, absolutely. We hear all the time about data theft and things of that nature. So you have to be able to protect your data in the best possible way. And then there are regulations around this of how the data should be stored, who can have access to the data, how data breaches have to be not have to be handled, and how the public has to be notified about them. So a lot of those issues are handled by the regulations, different regulations in different jurisdictions. And the performance is a big key here. That as you're dealing with a lot of data, as you're dealing with different types of data and different uses of this data, obviously performance becomes a key. That you have to be able to handle this in a reasonable time frame. And then there are also legacy technologies that are used today in many cases to handle data. And then if you go into the big data component, if you need to connect much more data than you did before and handle it in an enterprise fashion, there are limitations, and companies have to turn to some of the newer technology models in order to to satisfy business requirements. And then there are security concerns, as I mentioned. There is data can be used, for better or for worse, right? So there could be issues with security, that somebody else gains access to the data and can do a lot of harm with this data, with the data, or with the knowledge of the data. Some of the use cases that I've dealt with recently, had to do with basically making better investment decisions with consistent results and analyzing data for that. There's an algorithmic trading that's growing, where the real-time and historical data elements are being used to decide when is a better time to trade a particular instrument. There's a post-trade analytics piece, where you can actually analyze by recreating the environment, the market environment that had happened during the time of your trading, to decide whether the strategy that you utilized was the most optimal one. Risk management obviously also deals with some of the historical data and some of the current market events to decide whether you are risking too much, or whether you are in the right risk profile. Regulatory compliance, as I mentioned before, is also a big area here. Then you have to comply with different regulations, and most of those regulations have to deal with data. So knowing your customer, anti-money laundering, trade compliance, so on and so forth, they all deal with having access to the data and doing some kind of modeling, some kind of analysis around this data. Fraud detection absolutely is critical here. Again, you need to analyze your behavior, your customer's behavior, to understand whether this is a fraudulent transaction or a real transaction. Again, it requires real-time analysis and real-time approval or disapproval of a transaction that the customer is engaged in. Master data management, right? We talked about securities master and reference data updates and corporate actions and all those different updates within the securities world that is usually reflected within a data, some kind of master copy or securities master, where all this data is residing and has to be managed again in a low latency fashion. And then sentiment analysis is another big area, where basically companies analyze the news, analyze postings, analyze memos from the investor calls, and so on and so forth, trying to understand in real time, as soon as possible, what the context of this discussion is about, how the security might act around this information that's become available. So the faster you can interpret this information before everybody else, probably more money you can make out of this information processing. And then there's also customer intelligence, and that's where you're making real-time decisions, and you know how much to charge and what to do with with different customer segments and how to better position your products to them. I mentioned regulations, and that's where I basically breaking them down into categories here. The regulations have to deal with different reporting regulations, the model testing and real-time simulations, like MiFID II, for example. There's data privacy regulations about who can have access to the data and whether the data can leave a particular jurisdictions. Data breach notifications, what has to happen if the data breach has been discovered by the company. There are accountability frameworks, fraud prevention, some additional data analytics requirements, and data and cybersecurity space, right? Those are the main categories that I can see globally out of analyzing, dozens of different regulations in Europe and the US and in emerging markets, what's really happening. And those are the categories that you need to look after. And again, most of those categories deal with real-time data processing. There are also technology trends, right, that I said help to, for this to grow, for the big data and for data analytics to grow. And open source, a lot of open source ideas, open source technologies deal with big data and deal with how the data should be handled in the most performance conscious way. There are also methodologies now of moving data silos into data lakes and trying to make the data available to whomever is trying to subscribe to a particular data element. There are enterprise data warehouses. So from relational databases move more towards data warehouses where all the data again becomes available, becomes close to each other. Software becomes a critical component of the business, and the business make more and more data-driven decisions in their daily actions. There are also open architecture and open APIs, similar to the open source. They're built around better use of algorithms in the processing of data. And then artificial intelligence and predictive analytics and machine learning are all different techniques used in behavioral analysis, used in predictive analytics, used in various advanced data analytics methods utilized today. And then that all gets down to performance, stability, security, scalability are the sort of four pillars of having a successful system that can handle data and data analytics in real time. Right, so you need the performance to handle all this large data set. You need the stability of the system to make sure that everything is up and running all the time. You need the security, making sure that only the right individuals, only the right people are able to access the right applications are able to access the data. And then scalability, as the data is growing, as the capabilities of using the data and analyzing the data are growing, you also need to be able to scale it on your system. And then distributed systems, clusters and things like that, are being created to kind of handle those four elements: performance, stability, security, and scalability. And then the containers are also being used so that you could utilize machines and computers from various manufacturers, various operating systems, and utilizing them to really serve this purpose of doing real-time analysis on the data that's residing in multiple locations and using different architectures. And machine learning I already mentioned before, and then complex event processing is another idea that helps to process data coming in parallel from multiple sources and deciding how to handle the data intake in real time. And the decision support systems also deal with make a decision based on that data that's flowing from multiple sources in real time. And then those are the algorithms that are quite popular, so the Hadoop, HDFS, MapReduce. Those are some of the ideas around more optimal handling of data within the clustered environment. Matt, I suggest that maybe you pick it up from here for a few slides.
Okay, sure. Yeah, thanks a lot, Eric. Actually, I think now might be a good time to just throw in that a lot of those use cases that Eric mentioned are things that GridGain customers are in fact doing, right? So we've got companies like Cambridge Associates who are doing trade analytics in real time, Barclays and Fidelity who are doing a variety of real-time data analytics. We also have ING is doing real-time reporting, and that Macquarie Bank is doing a real-time risk analysis as well. And there's a company called Optim that is doing real-time decision automation for trading platforms. So these are all things that people are doing, and why are they doing them in memory with GridGain? So we've got there's a bit of a data revolution going on where there's more and more data, and at the same time there's also more and more of a need to interact with this data in real time. And this can be seen in web scale applications as well as in automated applications that don't require human intervention to make decisions. And while all of these trends are sort of going up, at the same time we've got the cost of RAM continuing to fall. So it's just making more and more sense for companies to turn to in-memory computing. If you could go to the next slide, please. So at the same time, I sort of covered this a little bit, and Eric covered it as well. You can see this dramatic growth in the amount of data that companies, or even just the world, is sort of dealing with. And at the same time, the price of DRAM and flash and disk are coming down. I had done an interesting exercise where it was like, well, if you could have even a gigabyte of RAM in a system in 1980, what would that have cost? And it was over $3 million, right? Then now a gigabyte of RAM is nothing. We have customers using a terabyte or even a pooled petabyte of RAM across all of their systems. So it's the technology is there, and the cost has come down, and that's what's driving the increased usage of in-memory computing. And we can see that in the next slide, which is based on a Gartner study, and they looked at the growth of the different aspects of the in-memory computing market. And they break this market out into an in-memory database, in-memory analytics, in-memory data grids, event stream processing, high-performance messaging infrastructure, and in-memory application servers. And you can see it's all, everything's growing, right? People are working with data in memory more and more. And the good news is that GridGain and Apache Ignite are platforms that provide all of that functionality. So you don't have to worry about which product you need to work with data in memory. You can just make a single solution. And so if we look at the next slide, we can see the trend is moving from, I love this quote from Gartner, right? RAM is the new disk, and disk is the new tape. Companies are going to stop. Ultimately, if it's a real-time decision and you're dealing with a large volume of data, disk isn't going to cut it anymore. And so at some point, it's not going to be, does it make sense to move towards in-memory computing? It's going to be, we need to move into in-memory computing. That's all. And, this is, when you move from disk to memory, you sort of automatically get 1000x performance gain. And when you then start to realize how you can use this performance gain, you can achieve a 10x or greater ROI. And the trick is that, while you're out there building all of these big data programs, you have to, there's no point in collecting all of this data and analyzing it, but not doing anything in real time. It's critically important to work with this data and the insights you can get from it in real time. And how can you do that? So let's look at the next slide. You can do that with using an in-memory computing platform like Apache Ignite and GridGain. So this is, there are actually a lot of sort of point solutions out there for in-memory computing, but it's important to look at using a platform for the sake of simplicity. And platform includes multiple features. So it's not just caching. We're talking about caching, parallel processing, in-memory SQL support, streaming analytics, and much more. GridGain doesn't replace an existing database. Instead, it slides in between the existing application and data layers to provide greater performance and scalability. And also, because of all of these features, when they're used together, we support both transaction and analytical use cases. And we have ACID compliant transactions as well as analytic support through the SQL functionality. And GridGain also integrates with all the popular relational database management systems, the NoSQL databases, Hadoop databases. So we can support just about anything that your data is currently stored in. And then we have a unified API with support for a wide range of languages to support your applications. And the other thing that makes an in-memory computing platform so powerful is that it can be deployed anywhere, either on-premise, in the cloud, or in hybrid environments. And so looking at the platform a little bit deeper, we can see that we've got Data Grid, the Compute Grid, SQL Grid, Streaming Grid, a Service Grid. We do Hadoop acceleration. Everything's built on advanced and automatic clustering. We have an in-memory file system as well, and support for messaging and events-driven computing. And also, we're built on a key value store. It's an in-memory key value store. So this gives us a lot of flexibility regarding the data structures that we can handle, where Eric covered those earlier, looking at the structured and unstructured data. So this is all built on Apache Ignite. And on the next slide, yeah, okay, great. You're ahead of me. So in 2007, the company came out with the first version of GridGain itself. And I think, basically what was happening was that our founders were running a software development and consulting company, and they realized that they were solving people's problems by putting data in memory, just, multiple times. And so they decided that it would be a good time to write a platform that could support this, because more people could benefit from it. And when they did that, they had the professional version of GridGain, and they had something called the GridGain Community Edition. Then in 2014, GridGain kind of rebranded the Community Edition to be Ignite, and then gave Ignite to the Apache Software Foundation. So, I guess the point of that long explanation is that it didn't start at Apache as nothing. It already was a mature product that was being used in the field for mission critical in-memory computing when it was given to Apache in 2014. So it took about 9 months for Ignite to graduate to be a full project, which is pretty remarkable. That makes it the second fastest project to graduate after Spark, and we all know that Spark is pretty popular too. And today it's a thriving environment, this thriving open source environment. More than 60 contributors. We're at over 1 million lines of code, and this is if you want to see what in-memory computing can do for you, I always tell everyone you can just download Apache Ignite. Until you start to get into the really trying to tweak performance and stuff. If all you want to do is play around and see what you can learn, download Ignite and start using it. And there are companies that are actually running complete Ignite platforms. So I'm not saying it's just a plaything. It's more than a plaything, but it's a good place to get started. So let's look at what you can do with an in-memory computing platform. So there's the data grid, the compute grid. If you can think about all these sort of multiple layers of functionality that work together to provide a really high performance distributed in-memory platform for computing and transacting on large scale data sets in real time. So it's not like a one trick pony where we're saying, import this data once and use it as a cache. No, this is actually like a real in-memory platform that can meet. What's incredible is we keep talking to customers who tell us, well, we got GridGain to do this we got GridGain to be a data cache. And then we learned we could also do real-time analytics. And so, I love hearing stuff like that. Like the tool is more extensible than customers originally realized it is. And so let's look at a bunch of things that we can do with these different components. So on the next slide, we have the data grid. Like I mentioned before, caching. It can be used to build a scalable SaaS solution. The compute grid does high performance computing. We're adding machine learning capabilities. A lot of our customers are doing risk analysis in the compute grid, right? So this is a distributed compute engine that passes your different compute tasks throughout the grid. And the SQL Grid is a hugely popular feature, and it's also, which is a great thing because it's also a big differentiator, where most in-memory solutions do not have full SQL functionality, and we do. And this turns out to be a tremendous boon to customers because they can leverage their existing SQL code base as well as continue to use all of their SQL-based tools, like their business intelligence tools. Streaming is another hugely important feature for real-time data analytics. I'm going to talk about these features more in depth a little bit later. this is just to sort of tie it all together. Hadoop acceleration is also important as we look at integrating historical data with current streaming data to make better decisions. And we also have a complex event processing engine and an event-driven design. So those are all the ways that you can use GridGain. So let's talk a little bit about how our customers are using GridGain. We sent out a survey late or early this year. We redid the survey, sorry. And we asked our customers, what are you using in-memory computing for? And so these slides here, so we asked all our customers, but what we did for this presentation is take a subset and look at only the financial services customers. And customers are doing high-speed transactions, real-time streaming analytics, database caching, HTAP, building a hybrid transactional and analytical processing framework, and they're doing application scaling. Apache Spark acceleration is another thing that we do, faster reporting, Hadoop acceleration, stuff like that. So we're looking at speed and scale, fast transactions, streaming data analytics. On the next slide, we can see we asked people which data stores are they most likely to connect to, and I think we went 2 slides. Okay, thank you. So they're most likely to connect to Cassandra, which is actually really interesting. So we have a custom connector that we wrote to connect to and enhance Cassandra. Actually, I happen to think this is sort of a cool thing that you can do with GridGain, which is use us as a SQL engine on top of Cassandra. People are also using us to move Oracle data into memory to enhance MySQL for greater, actually from both MySQL and Postgres, we're sort of doing the same thing where we're adding better performance and scalability. Microsoft SQL Server, MongoDB is sort of an interesting one because Mongo has their own ability to do stuff in memory, but it turns out people prefer to use GridGain and Apache Ignite. And then on the next slide, we can see like which of the product features people are using. And then now this is important to understand that this is for the financial community. Compute Grid, where we're talking about the real-time analytics on this webinar, are this is sort of backed up as a real-world use case because customers are using the Compute Grid. That was the #1 real-time, the #1 use of the in-memory computing platform, followed by Data Grid, the in-memory file system, the service grid as part of a services-based, service-oriented architecture. SQL, we have full ANSI SQL 99 compliance as well. The streaming grid, Spark shared RDDs. This is actually a pretty big feature if you're running Spark, where you're no longer limited to have one RDD per Spark job. You can have one RDD and share it across Spark jobs. And we also have support for containers. Jarek talked about, right? The big trend is to move towards distributed computing that's provisioned and orchestrated through containers. And then we get into accelerating Hadoop and things like that. If we look at the next slide, we see where our customers are running GridGain and Ignite. So, in finance, right, there's no surprise here. On-premise, right, this goes back to all the data governance things that Eric was talking about earlier. And then also people are running in AWS and in their own private clouds. Looking at the next slide, we asked people which languages they use to access their data. SQL and Java are far and away the most popular. C++ is up there, as, which is, again, something specific to finance. In other verticals, we don't see C++ as often as we do in finance. Scala, Groovy, Node.js, and then sort of trailing is .NET and PHP. So then if we talk about different things that customers are doing, we've sort of touched on a lot of these in the, just in passing as we've gone through the webinar. So we've got customers doing, hey, Eric, do you want to run through this or should I keep going?
No, I can handle this. Yeah, thanks.
Okay, thank you.
Sure. Yeah, so this is related to some of the discussions we had before about use cases. And obviously, as I mentioned, most of our customers are using us for big data analytics, for financial analysis, risk management, compliance and monitoring, basically all of those areas that I mentioned earlier that are showing as the top areas where big data analytics and real-time analytics are being used. And as you can see, the number of financial institutions we're very proud of, right? So Citi and Sberbank and Fidelity and Jefferies and Barclays and so on and so forth, they've chosen GridGain system to actually run most of those big data analytics tasks that they have to deal with. And I'll just cover maybe two case studies briefly, how the data is being used for analysis on GridGain. And one is Misys, which is a very large financial software vendor, headquartered in the UK, but that deals with about 2,000 customers in 130 countries and used by 48 of the world's 50 largest banks. And it's basically a financial analysis tool that helps with corporate banking, with risk management, with treasury and lending functions. And one of the challenges was that they wanted to eliminate the data processing bottlenecks, as they've seen huge amounts of trade and accounting data and market data that needed to be processed. And customers also needed high-speed transactions and real-time reporting, as well as the regulatory compliance. So they chose to implement GridGain on commodity servers, where the data will be stored in memory. Both transactions and market data in real time would be processed by the cluster, and then the reporting would take place, the heavy calculations and regulatory compliance all happening on parallel processing across this large cluster. So basically, they've integrated trading systems with cloud-based components of different financial instruments, and they used this cluster with GridGain on top of that to reach results that they wanted. As you can see, the director of product management at Misys said that with GridGain, we have achieved real-time processing of massive amounts of data, eliminating bottlenecks, enabling us to offer next generation financial services to our customers. So basically, this is the hosted platform of Misys with multi-tenant capabilities, where a lot of customers come in and they can analyze their portfolios, they can analyze in real time their needs, their situations with portfolios, with their situations with risk management, their situations with pricing. And the second use case I wanted to briefly cover, as we only have a few minutes left, is Sberbank, which is the largest bank in Russia and Eastern Europe, and the third largest in Europe. And they also had seen significant growth in terms of transactions, in terms of data that had been hitting their servers. And they wanted to prepare for even further growth, for the sort of build a next generation data processing platform. And they've looked at about 10 different competitors that all work within an in-memory space. And they did the tests, and they basically the tests they ran were about 1 billion transactions per second, and they ran them on 10 Dell R610 blades with about 1 terabyte of memory, which cost them about $25,000 to set up. And with that, they were able to achieve those 1 billion transactions per second, and they were also being able to restart the cluster in under 5 minutes, which was required by the regulators, and they were able to comply with various regulations that they had to worry about, as well as having full SQL support and full fault tolerance, again, as required by the banking regulator. This is a quote from the CEO of Sberbank, Herman Gref, that said that while we've looked at different products and we found GridGain to be the best, to show us the best performance amongst all of the companies that we've analyzed, and we're able to now go with virtually unlimited performance and very high reliability with our product. So this is quite an accomplishment, I think, and quite an interesting quote from one of the most powerful CEOs within the financial community. Matt, maybe you can briefly cover, because we only have a couple of minutes left. Mm-hmm.
Right. Okay. I'm going to fly through this now, people. So the GridGain in-memory computing platform, I touched on a lot of these things, talking about support for different data backends and support with our unified API for different applications. I talked about our clustering and compute, and as well as the data grid and SQL Grid functionality too. So if we just sort of run through what these different things are, let's start by looking at the data grid. I'm not going to read everything on each slide to you. If you advance the slide, please. Thank you. And so the data grid, basically, we put the data grid in between your existing application and your data layer, and move data from your disk-based data store into memory. And then that gets you greater performance, and then we distribute it in memory across a cluster, and that gives you greater scalability. As I mentioned, this is a Java-based in-memory key value store. We've got a whole variety of replication and partition options. You can either let the system do it for you automatically, or some of our customers will evolve beyond doing things automatically and start to tweak things themselves. The data grid supports ACID compliant transactions, which is important because not every in-memory system supports ACID compliant transactions. It's something that really sets us apart from the rest of the pack. And so then looking at the next slide, the in-memory SQL grid sits on top of the in-memory data grid. And this really lets you leverage the full power of the data that is stored in the GridGain in-memory computing platform. The SQL Grid, don't be confused by other competitors who talk about having SQL support and they really don't, or they have support for like 3 commands. We're fully ANSI SQL 99 compliant. So we support SQL, all SQL commands, which includes DML and DDL. So you can work with the data as well as query it. And actually built into our engine is geospatial support, which is fantastic for this real-time analytics use cases that we've been discussing. And if you look at our next slide, it talks a little bit about the in-memory compute grid, which is this parallel processing. And we have a lot of sophisticated functionality around this, where the system can either automatically load balance the compute jobs, or you can manage them yourself. You can do interesting things like run the compute job on the node that's holding the data that that compute job will operate on, and then you remove the network as a bottleneck and achieve greater speed. And if we look at our next slide, it covers support for in-memory streaming and complex event processing. Um, Basically, it's actually kind of amazing. It's like 2 lines of code to start to consume a stream. It's very similar to the way that like Kafka or Spark would consume and process a stream. And then you declare an event window and run whatever analytics on that stream in that timed window, and it can get more complex from there as well. We'll also index the data as we read in the stream, which is something that a lot of other streaming analytics solutions don't do. And the advantage of this is that we then give you greater performance on your SQL queries because they've already been pre-indexed. Looking at the next slide, this talks about our in-memory Hadoop acceleration. We can either connect to your existing disk-based HDFS. We can take all that data and bring it into our in-memory file system, and then replace the Hadoop's MapReduce with our MapReduce and run it on our compute grid. And this gives up to 10x faster Hadoop performance. And our last slide is just to show you the differences between Apache Ignite, which is also it's the same as our professional version. The professional version adds better support to Ignite and faster bug fixes, faster releases of bug fixes. And then GridGain Enterprise adds a management and monitoring GUI, enterprise grade security, and more failover and replication support, as well as rolling production updates, which is essential in an enterprise environment. So you can update nodes individually and automatically without bringing down the whole grid, which is great for a mission critical application. And I think that just about wraps up what we wanted to talk about today.
Great. Well, now I'll ask the audience if they have any questions. And if you do, please enter it in the GoToWebinar questions window. And we'll just give people a couple seconds. There haven't been any questions so far. So I guess you guys did a bang up thorough job. And thank you. All right. If you're going to be in the Amsterdam area next week, our In-Memory Computing Summit Europe starts on Tuesday. And you can find out more information on the GridGain website. We'd love to see you there. Okay, guys, well, it looks like there are no questions, so I wanted to thank you today for your great presentation.
Okay, thanks a lot.
And thank you, audience, for attending. We hope to see you on a future event. Thanks again, guys.